Day 7, more modeling problems. We're basically doing the same thing that we did yesterday. We're just going to be doing cylinders today, so a more complicated shape to find the volume or surface area of. Same concept though. Alright, so I'm going to do example 5. The volume of a closed top cylinder is to be 500 centimeters, cubic centimeters. I'm going to underline that. Volume of a closed, also is important, cylinder is to be 500 cubic centimeters. Determine the radius and the height of the cylinder that uses the least amount of material to build. Okay, so I see two things happening here. Volume and surface area. So first of all, with a cylinder is made up of two circular bases and a rectangle that wraps around that creates the lateral sides. The volume of a cylinder is area of the base times the height, and since the base is a circle, it's pi r squared h, where r is the radius, h is the height. The surface area of a cylinder, especially because it's a closed top, meaning it's going to be made up of two circles, and like I said, and that rectangle, is 2 pi r squared plus 2 pi r h. This is a formula that we derived last year in geometry. I would give you this on your test, so you don't have to memorize it. But what you do need to memorize is when to include two circles. So again, pi r squared represents a circle, or one circle. So if this was an open top cylinder, I would only write pi r squared. This 2 pi r h is your lateral area. That's always the same. Okay? It's only this number that changes depending upon whether you have an open or closed cylinder. And again, since it's closed, I know there actually are two circles that exist. Alright, moving on. So let's fill in what we know. I know the volume is 500. And that's about it. So now it's where I have to kind of make a move. I gotta go from what I know the most information about, which is the volume, and work towards what I'm trying to find, which is information about the surface area. So I need to look at my volume formula and solve for a variable that I can plug into the other one. Sometimes students say R, which like puzzles me. Let's solve for H, because if I can isolate or rearrange these variables in terms of H, I can then substitute it in over in the surface area formula. So in order to isolate H, I would divide by pi r squared. And for H, you guys are seeing me plug in 500 over pi r squared, because that's H. Okay, so now's where we go to our calculator. This is where we're plugging this into y equals. So every y value is going to represent the surface area of this cylinder. Okay, so I paused the video so you didn't see me wasting time typing it in, but as you guys should see, didn't mean to do that. There we go. As you see, I am using the alpha y equals feature to do 500 divided by pi r squared, which in this case is x. That's really important, otherwise your order of operations will be messed up. The rest of this is really unexciting. I have 2 pi x squared plus 2 pi x times 500 over pi x squared. So again, x in this case is representing r. So now this is where I go to my graph. So let's just do a zoom 6 so that whatever my window was, it's reset. Now, you're seeing some information over here, but keep in mind that this is irrelevant, because if you have a negative x value that's representing a negative radius, which can't happen in the real world. Really what you're wanting to focus on is what's happening in quadrant 1, because this would be a positive radius and a positive surface area. So I'm going to go to my table of values to get an idea of what this thing is doing. And it looks like at x equals 1, it's already up at like 1,000, and then it starts to drop down. So I'm going to do for my y maxes, I always round up, 1,500. There you go. So keep in mind, you're looking for the least amount of material to build this cylinder, aka the least amount of surface area. So in my graph, that's representing this minimum. Again, I don't care about anything over here because that's not going to be a part of the domain that would make sense in the context of this problem. So if I'm looking for a minimum, I do second trace min. For my left bound, I'm just going to type in 0 because I know that's furthest to the left of this. I'm going to type in 10 for my right bound because, again, I know that's furthest to the right. My 2 arrows will be pinching in, so yeah, go ahead and guess. And that's my minimum. So what I'm going to do, I'm going to pause this video to give myself some time. I'm going to sketch what this looks like over in my work, and I'm going to label the minimum with this information, rounded to the nearest tenth. Okay. So 4.3 was my x, but keep in mind that when I plugged this into my calculator, I did pi x squared plus 2 pi x squared plus 2 pi x. So x is really representing the radius here. And as I said over on this side, y is representing our surface area. Now there's one other thing it asks us to find. It says determine the radius and the height. Okay, so I got to look at my work. I actually do have a formula for height. It's right over here. So I know the height is going to be 500 divided by pi r squared. Since I ask you to round the radius, I'm okay with you plugging in the rounded answer. Just plug it in our calculator and then we'll round that. Okay, so if we do plug that in our calculator, we get 8.6. I'm not going to show that computation. You guys can double check that. So again, that's our height. 4.3 was our radius. Now, it actually doesn't even ask for what the minimum surface area is, but it is 348.7 if the question did ask. All right, next I'm going to do example 7. So you wish to maximize the volume of an open top storage bin with a square base and vertical sides. The surface area of the box is 108 feet squared. Find the dimensions of the box that will maximize the volume. Okay, so let's draw a picture of this. So I have an open top storage bin with a square base. So we'll say that's a square. That'll be the opening of it. All right, good enough. So this will be our open top prism. Okay, it's got a square base. Let's call that x by x, and we'll call the height h. Now, they tell me that the surface area of the box is 108 feet squared. So surface area is just the area of all the sides added up. So, for instance, the bottom of this is a square, which is x by x, which means the area is x squared. So surface area equals x squared. Now, take this piece by piece. This front part right here is x by h, because that's the height. Same thing with the parallel face behind it. That's also x by h. So is this one, x by h, and the one off to the side, x by h. So x by h, x by h, x by h, x by h. So what this means is that we have 4xh for the area of the sides. So I'm going to set this equal to 108. Now, the volume, that's what we're working towards. Volume of any prism is area of the base times the height. So the volume equals x times x, because that's the area of the base, times the height. Now, this is again where you got to make a move. You got to solve for one of the variables from the surface area formula, the stuff you know the most info about, to get it into the volume formula, because this is what you're trying to get information about. I can easily solve for h here. I wouldn't solve for x because there's two x's here. That gets a little confusing. So I'm going to go ahead, I'm going to isolate the h. So I subtract the x squared. And then I would divide by 4x. Okay, so I'm going to write h is 108 minus x squared all over 4x. And then I'm going to plug this in for y equals. So that means every y value is representing the volume, and then x is representing the base. Alright, so I've typed this in my y equals. I've also used alpha y equals so that I can get the fraction. If I do a zoom 6, it's going to be a pretty unexciting graph, but I just do this to reset it. Now I'm going to go to my table of values to see what's actually happening with the function. I can see it gets up to like 108 and then it starts going down to 88, so I'm going to change my window. So my y max is to like 200. And I might as well get rid of any negatives here. So I'll go x min 0, y min 0. So I really only care about quadrant 1. And there you go. I really see enough of the graph that I get that maximum point. So I do second trace. Second trace. I'm going to hit option 4 for max. I'm going to get to the left of it. Get to the right of it. And our coordinate is 6, 108. Okay, so again, what does this mean? The x value is representing how much what the base dimensions are of this prism. Y is representing your volume. So it said find the dimensions of the box that will maximize the volume. So our box is going to be 6 by 6. And then for height, we got to do a little bit of math. Our height is equal to 108 minus x squared all over 4x. So I'm going to plug 6 in for x. Okay, so 6 squared is 36, 4 times 6 is 24. When I go ahead and simplify that, I believe it's 8. Ha, I totally remembered wrong. It's 3. All right, I was trying to remember the answer key from earlier. All right, if you plug that in, you'll end up getting 3. So the dimensions are 6 by 6 by 3. That's what's going to maximize your volume. Now, the next problem is a little bit of a different type of modeling. I have a rectangle that is underneath a parabola. It says the area of a rectangle has one corner of the graph, or one corner on the graph of y equals 25 minus x squared, another at the origin, a third on the positive y-axis, and a fourth on the positive x-axis. Express the area of the function, or the area of the rectangle as a function of x. Now, what I want you guys to understand is that this is just one possible rectangle that could be created. Let me show you what I mean by that. Okay, so what I have graphed is the function y equals 25 minus x squared, so that is a parabola that has been shifted up 25 units and reflected in the x-axis. I have this point A being my point on the parabola. And then C and B, as you guys can see, no pun intended there, are on the x and y axis. D is at the origin. So you can see how by me dragging this point A, the area of the rectangle is changing. It starts to increase, gets up into the 40s, and then starts to decrease again. So I want to represent or come up with a function that's going to represent every possible area for this function in terms of what's happening along the x-axis. So for example, this has an x-axis, if I move it right there, where x equals 3, that changes then or affects what the y distance would be, which then effectively changes the area. As you guys can see, I can change the x to be 2, I can change it to be 1.5, or really whatever I want. I want to represent every possible set of dimensions. So with that being said, keeping in mind that this is just one possible rectangle, no matter what, it's going to be some x distance and some y distance. X because it's along the x-axis, y because it's along the y-axis. So area is always equal to length times width. Let's call that x times y. In no particular order there, we'll just say x times y is our area. Now it says in terms of x, well, what's another name for y? Well, we know that this function is y equals 25 minus x squared. So I'm going to substitute in for y 25 minus x squared. Because the point is on this function, our height is always going to be related to what 25 minus x squared is. All right, so this would be our function. A equals x times 25 minus x squared. Now, the domain. So really, the x's here. I only care about from 0 to 5, but not including that, because otherwise I wouldn't have a rectangle. So actually, 1 second here. Basically what this means is that if I had x equals 0, do you guys see how I don't even have a rectangle here? If I drag my point so that it is on the y-axis, okay, that doesn't even give me a rectangle. But as soon as I move it to the right, I start to get a rectangle. I go all the way until I get to 5, and then I don't have a rectangle again. So my domain is between 0 and 5, but not including it, because then I wouldn't have a rectangle. Then I wouldn't even have an area. So it says, for what value of x to the nearest thousandth is the area the largest? So now this is where we're looking to maximize our area. So I plug this in for y equals, and see what happens. Okay, so I went ahead, I plugged it in for y equals, I did a zoom 6 to reset my window. I'm going to go ahead and go to the table of values to see what's happening. So it looks like our area gets up into about 48 as a maximum, as you guys were even seeing in my applet when I was dragging it. So I'm going to change my window to be a y max of like 60. I'm just going to overshoot here just to make sure I get a good image of this. So I don't care about anything to the left because this is representing a negative x value, so a negative distance, so that's not important. And I also don't want any negative y's because that would be a negative area. So I'll even change my window a little bit more here so that the x min is 0 and the y min is 0. There you go. So every y value on this function is representing the area. Every x value is representing that horizontal distance along the x-axis. This point right here is the biggest area. So I'm going to go ahead, do second trace, option 5. Oops. Second trace, option. Oh, sorry, I said 5, I meant 4 for maximum. Find the next. And there we go. So it says to the nearest thousandth, which is tens, hundredths, thousandth, 3 decimal places. I got 2.887. And 48.113. Now the question is, for what x value? So the x value would be 2.887. So essentially what this means is, let me change this over for a second. Drag this guy into the frame a little bit better. Okay, so what this means essentially is that if I move this point A, so that it's about just a smidge to the left of 3, so about 2.88, that would give me the biggest area, which is about, according to my math, 48.113. So that's actually 48.099. That's actually pretty close. If I move this a smidge, oh, there you go. You can kind of start to see where it starts to hit 48.11 in there. Okay, this x value would give you the largest area. So again, this is representing your x distance, this is representing your area. So if I did ask you what is the maximum area is 48.113. All right, so then just one more problem here, guys. Slightly changing of the modeling here, where I still have a parabola, but now I am bound, let me zoom in, on both sides of the x-axis here. So this is some positive x distance, and then this is another positive same amount of x distance in the other direction. So what you guys are seeing is 2x along the bottom. Okay? So for example, if you were out 3 to the right, you would be out 3 to the left, which means that total distance across would be 6. So to represent every possible distance along the bottom of this, I'm just going to say it's 2x. Because again, whatever it is to the right, it's going to be doubled to get all the way over to the left. Okay, same idea. This is going to be a y value. Now this function is y equals negative x squared plus 16. Sat parabola shifted up 16 units. So if I want to represent the area of this function, so same idea as the last problem. Area is equal to length times width, or 2x times y. But instead of saying y, we're going to say negative x squared plus 16. I'm going to go ahead, plug this in for y equals again, and look at a graph. Okay, so I'm looking at my maximum area. It looks like I'm getting up to about 48 again. So maybe I'll change my y max to 50. I'll also change these to 0. Okay, it looks like I just made it. So again, this function is representing the possible area of that box, that rectangle that's underneath that parabola, those certain constraints. I'll do second trace, option 4, to the right of it, to the left of it, pinch in, and I'm getting 2.3 and 49.2. Oops, sorry. Like that's the coordinate that I'm seeing. Okay, this is my x, this is my y. The x is representing that distance to the right, which would then be doubled to get the whole base of your rectangle. Y is representing your area. So the question says, express the area of the rectangle as a function of x, and find the value of x so that the area is maximized. So the answer to this question is just the x value, which is 2.3. That would be the answer. If it asked you what is the maximum area, you would say 49.2. Okay? And that's the end of modeling. And the end of Unit 2B. I'm going to awkwardly end the video now.